Alright everybody, welcome back to another update, and this is a new update on one of the other significant tornadoes of the Friday, March 14th Pi outbreak. And yesterday we released a video on the Cave City tornado, and that was certainly a very interesting short study that we did. Fairly lengthy video for quite a lot of things to cover, but today we'll cover a couple of other different points, and we'll just stylize and make it a little bit unique in each video for things that we discuss about, because today we're talking about the Diaz EF4 tornado that occurred in Arkansas as well, the highest rated tornado of the outbreak and the highest rated tornado in Arkansas since 2014, the Vilonia EF4, a very infamous tornado on the April 27th 2014. April 14th is April 27th, sorry, is certainly quite a cursed day, to be honest. And we have so the tornado was rated 190 miles per hour for the maximum DI. Tim Marshall yesterday did further investigation and confirmed that one of the points that were made standing was that the nails were standard, so that there was not anything about the nailing of the foundation or that was swept clean that could defy any further rating, because there was kind of a talk in that was going on, as typical of whether this thing should get an EF5 rating, and of course the EF5 rating has been nullified since 2013, and I do think that it will remain like that due to the stricter use of the Enhanced Fujita scale. The Enhanced Fujita scale is obviously very limited, but quite primitive still in the way that it demonstrates representing tornadoes as compared to other scales. Like the VEI index for volcanoes is a very specific and very interesting index that actually does much more better in defining a volcanic eruption, for example. So with the Enhanced Fujita, as for what it does, it is still very impressive, and Television did use a great mind to come up with this, and it was passed on to become the Enhanced Fujita scale. And we do still have quite high accurate measurements that are consistent with each damage that tornado does, but it has its caveats, especially in the higher ratings, particularly when you talk about EF4 and EF5, and that is the main talk here. So what we're looking at back here was the same imagery that was shown yesterday, but this is just to remind that this is what the sort of live imagery on radar was representing, and this was during the peak part of the outbreak, so when there was a mature line or a so-called arc of supercells that was from southern Missouri to central to northeastern Arkansas, where we saw these significant tornadoes. And one of the ones, I do believe this image is like slightly after the tornado occurred. The Diaz tornado occurred somewhere in northern Arkansas, and it was certainly very significant. Alright, so this is the information provided. So this tornado had been on the ground for 18.62 miles, so fairly long track, not all too long track compared to the other tornadoes, but still quite a prime environment. One of the things I have noticed is that with this tornado, we'll show a visible imagery of the tornado itself, but when you have certain types of tornadoes, it can affect the longevity and the stability of the life cycle of that type of tornado. And so this tornado was mostly, as for what it says in maximum width here, of a mile wide, that could have been the case, but for the most significant part of its life, when it did the most significant damage, it was a stovepipe, much more narrower tornado, which by determining from the theory of angular momentum, when a tornado shrinks, it has to conserve the angular momentum. So in order to conserve the angular momentum, it must increase the wind speeds despite the diameter of its width decreasing, and so that's why the damage was much greater likely, and the DI was very highly rated. And so the intensity of the tornado, as with theories provided by Werman, et al. 2044, and some of the other theories, tornadoes of this intensity can be up to 1.5 times their EF scale, and so it's very likely, and very likely, the tornado could have been easily in the EF5 range, over 200 miles per hour, and by that logic, it could have been up there with some of the very significant tornadoes like Vilonia, which is very significant and a very high intensity tornado, recognized for its high intensity. One of the other things is you get a ghost wind field, and we'll be discussing that and shortly after in a bit. Alright, so this is just looking at the dynamics that were in play to cause this significant outbreak. So, like previously discussed in one of my recent videos, this trough ejection moved into the central to eastern part of the Central Plains towards the Ozarks region, and you can see how it's a very compact, tight low with very, very tight isobars here. And this right here is the jet max where the yellow colors are highlighted, and along that is where we saw the greatest lift for initiation of storms. And so this is just was what was a GFS run, previously deterministic of where the track would be. So this is not necessarily what actually where the trough was. I believe it was slightly to the southeast of this, but this is just an image to demonstrate theory. And one of the things that were mentioned was the idea of defluence, and so how defluence doesn't necessarily create a large-scale ascent that allows for initiation of thunderstorms very quickly. Because by theory, a storm that from defluence, it would take upwards of 3 hours if it was to occur through that process. So it cannot. So one of the things about this is that how did these thunderstorms develop so quickly? Because they were very immature, being like low reflectivity cells that became mature supercells within just an hour and a couple of hours at that. And so what was the reason to cause that? One of the underlying theories is that when you have this sort of defluence, the defluence actually degrades the SIN, so the convective inhibition that is ejected from the desert southwest and northern Mexico into the Central Plains, and that's what the defluence is most effective at doing. Of course, the large-scale descent from the left exit region of the trough creates this rising motion for air parcels to lift and reach the LFCs. And when they reach this, it allows the thunderstorms, the air parcels to rise. But the main thing about the actual strengthening of the thunderstorms and allow them to occur is through the lower level 850 millibar response, the near surface level response from this upper level pattern. This is a 500 millibar, much greater in altitude, and this causes a low level response when you get significant this sort of wave troughing that ejects into Central Plains. This defluence creates this low level pattern where you get a surface low, a mid latitude cyclone that develops, and these cyclones allow for frontogenesis to occur and horizontal advection regimes where you get to where the low level response lifts these air parcels from the surface through dry lines. And one of the features that did initiate the thunderstorm was a dry line, where you have this strong westerly flow across the dry side of the dry line, which is where the EML is, and then you have the moist layer beneath. And what happens when you get the westerly flow across the dry line is that the westerly flow allows the dry line to wedge underneath that moist air parcel, and that moist air parcel is now free to lift to its LFC, so it allows it to become buoyant, rise across into the air. And thunderstorms, this buoyancy is required from the Cape, and the Cape is what is built up through the day through different types of things, but primarily surface heating. And when the air parcel has the availability to that buoyancy, that Cape, it is able to use the energy to become a cumulonimbus, so like a thunderstorm complex. And so that's one of the underlying theories, is that is how a quick response is to allow for immature cells to become mature supercells. One of the things also is, now we're looking at the tornado itself, so now we're looking at the mesoscale level, is that when you have a so this is what we're looking at as the debris ball, and when you have these different diagrams, what it's showing is how high the debris is aloft and how significant the debris is, and by the correlation coefficient, so the measure of the different particles relative to each other. So you have these similar coefficients that are of red color, and you have the blue, which is of much significant larger debris, which is not correlating to the smaller raindrops that are in the storm itself. You get this correlation coefficient drop, and so it becomes blue in this highlighted false color. But the most significant part about this imagery is not necessarily shown by the image itself, but but you can tell by kind of how the low resolution nature of this radar scan, and you can see how it's not necessarily high resolution. You get this long stretched pixels. This just suggests that the range of the radar is very high up and scanning very high in the atmosphere. And so one of the observations was that debris was lofted by this tornado up to 40,000 feet in the air. And so by perspective, EF4 range tornadoes only roughly typically need to lift debris above 15,000 to anywhere up to 30,000. The Greenfield tornado roughly lifted debris around 30,000 feet in the air, which is a very rare feat alone. So for a tornado to lift debris up to 40,000 is very, very significant. In fact, I do believe one of the highest debris lifted, one of the highest debris heights that a tornado lifted was Washington, Illinois tornado in 2013, which lifted somewhere around 40-something thousand feet. So this is up there with one of the most significant debris debris measurements measured aloft in the tornado. So again, to demonstrate how significant it was, and it was just north of Diaz. And this is the imagery. So this, one of the things that I was going to mention was the ghost field. So when this sort of term is colloquial by me, but what it basically means is that there's a larger wind field radii around the surrounding tornado, and that is not necessarily visible to the eye, because when you have raindrops and condensation, it's visible to the eye. But when there is the absence of that, you cannot actually see the wind itself. So what I'm saying is that you have this main stovepipe condensation, which is clearly this tornado is at peak intensity, causing its damage, and this is just prior to it downing one of those, I believe, like news station or like electricity for, grids, and this is where you can see that the very near surface, this sort of debris, dust being kicked up. This is where the tornado's main vortex center is, and we can see it. But the larger wind field radii, we cannot see around it, and that is what is meant by a ghost, like a ghost wind field, is that the wind field is much more greater. Okay, and coming back to this, we're looking at one of the previous satellite images that are prior to the damage that occurred from the tornado itself. So this is a well-built house. This is the house that was, I believe, providing the highest DI for the tornado. So again, a very well-built house. It almost looks like one of the houses that were in Moore, Oklahoma, during the 2013 tornado, where you have these really well-built houses. And so that's the before, and this is the after. So you can see the foundation has been completely, the foundation is bare, and so all the debris has been lifted from the house itself. And again, it's a very well-built house, so it was certainly demonstrative of a high-end DI. One of the other things we noted was not significant enough tree debarking, which is subjective, but it's actually very subjective, because in the 2013 EF5 tornado, the several trees near the well-built houses were not debarked, to be in specific. So here, with such a narrow stovepipe tornado, it's very hard for it to provide the same strength wind field radii very far from its center to debark trees, as opposed to the wedge EF5 Moore tornado, which was much larger but had a violent core in the middle. And so again, even that tornado did not completely debark all the trees. So again, it's a very subjective case, and the type of trees matter also, with the hardwood and softwood material, and then you have the surface roughness, which is like an index to the tree's resilience. And so some of these trees are completely toppled and ripped apart and even lifted from the topsoil, which is significant and does occur. But one of the things that is most commonly noted for violent tornadoes is tree debarking, and apparently these trees were not debarked as much to warrant the higher rating. And so the standard nailing also was something that prevented it from getting a higher rating, because if it was really like well constructed, it would be beyond just the standard nailing. And so this just warrants an EF4 rating by the measurement, at least the details of what the DI has specified. And with that, I think everything has been mentioned about the tornado and the dynamics at play. So again, really significant tornado, and this is certainly another update to where we'll discuss other tornadoes that occurred from this outbreak, and we'll also discuss the Saturday outbreak as well, March 15th. And yeah, overall very significant violent outbreak, and definitely something that's been very recently, like it's very recent, and it reminds me of the 2008 Super Tuesday outbreak, which is a very significant outbreak that occurred as well. And so with this, I'll see you guys in the next video.